Before we continue, let me introduce the stencil diagrams. A stencil diagrams is a representation of how we are computing the derivatives in space and in time. So consider that you have a field rho at the space point I and at the time point n plus 1. The stencil diagram shows how this future point is depending on the values at the old time step. In this case here, this would be a derivative that to advance one point in time, you need the values of 2 points to the left and 2 points to the right. Let's consider first then the naive scheme. The naive scheme defines the flux by averaging the adjacent grid points. You want to find the flux at the point I plus half. It takes the density at the point I and the density at the point I plus 1. So this leads to this recurrency relation. For this recurrency relation, you see here that the future point, which is this one, depends on the middle point, this one, the point I plus 1, which is this, and the point I minus 1, which is this. And this is the solution. As you see here, the red was the initial condition. We started from a Gaussian, a box function, a triangle, and a half ellipse. In blue here is the solution after you ran a period. The oscillations, they grew exponentially.